All right, so let's take a look at modeling some of these classes and relationships in this class diagram. So first, let's model the section down there. So let's create a couple of sections. We'll create 4 different sections. Say DB sections. We're going to insert, and the name of the section will be 1, the seats for the sections, and then the course they belong to. Presumably, these are courses that exist, right? And these courses might have some unique identifiers. So these could be treated like a foreign key, right? That are referring to courses that exist, right? Obviously, we don't have courses, but that's fine, right? We're not. Notice that we're not actually enforcing any. We're not enforcing any referential integrity, right? If these were actually foreign keys and the courses don't exist, it wouldn't allow us to insert them, right? So we're not doing that, right? We're not enforcing any referential integrity. So let's create a couple of sections, again, just to play around with this. So we'll say db dot, so db dot sections dot insert, and we're going to insert what? Let's see, a name, a 1, and seats is 12. And course that it belongs to is course cs101. cs101. Okay, we created that. Let's create a couple more. So 1, 2, 3, 4. And okay, so let's create another one for the same course. It has more seats, and this is section 2. And we'll create another one for another course with more seats, and this is section 3. And another one for the same course but more seats, and this is section 4. And we can list all the sections. db.sections.find. Now this is hard to read, so we can do a pretty at the end of this, so that makes it a little bit easier to read these sections, right? Once we have that, let's put this over here. Once we have that, we can start asking for different things. Like, for instance, give me all the sections for a particular course, right? We can say those are all the sections, but I can filter and say I don't want all the sections. I want the sections whose course is 101. And there are no sections 101. What? Oh, CS. Sorry. Okay, notice that it comes back only with those 2 sections. Okay. What if I say course 101, but with seats of 12? Notice it comes back just with 1. All right. So this JSON object of a where clause is treated like an AND clause, meaning this has to be true and this has to be true, right? And when all the predicates are true that pattern match, then it comes back with so the default for all the predicates, all the fields, is to treat it as an AND clause, right? Without an explicit AND, right? So it's an implicit AND. You can also use explicit ANDs, and we'll see that in a minute. Right, so this one returns just that one section. You can also use ranges. You can say, well, give me the seats that have seats that are greater than a particular value, so greater than 30. So for instance, we can say find, and then you can say with seats greater than 30, right? Again, all the predicates that you put in there, all the where clauses are a JSON object, so they have to be formatted. So it's a JSON object. There it is. It's a JSON object. And then there's a command G greater than GT. Notice that it starts with a $sign. So $sign means that this is not a field. It's not a value, right? It's an operator. Right? And first the seats, right? And then what the operation you want to do, right? You want to compare it against something. So you want to compare seats, compare it against 30, right? And this says, retrieve for me all the sections whose seats are greater than 30. So it returns those two, right? The ones that are 34 and 45. Okay. Or you can combine them. You can combine with greater than and less than, right? With and, $and allows you to create arbitrarily complex Boolean expressions, right? And use an explicit and as opposed to an implicit and. Okay, so here, let's erase that. We can say and then and takes as argument an array. See that? And then an array, a JSON array. So colon and then an array, and that array, it's two different predicates, right? Seats greater than 30 and seats less than 40. Right? So we can say 1 and then 2. And the first one is that we're doing seats, and here's the comparing for the first one, and the second one is also seats. And here's the comparison for the second one. So first one, we're going to say that it's greater than 30, and the other one is less than 40, sorry. And there's only one section that falls within that range. Make sense? We can also do sorting, right? Just like we can do pretty. Let's go back to the previous one. So pretty. Notice that this pretty is showing the documents, right, in the chronological order in which they were inserted, right? We can change that. We can sort it maybe by the number of seats, right? And we can add a sort at the end of this. Okay. And sort allows you to specify which field you want to sort by. Right? So in this case, we're going to say we're going to sort by seats, right? And 1 means ascending, and -1 means descending. Right? So we can say seats 1, which was already ascending, right? So that didn't do anything. But if we do -1, then it's 45, then 34, descending, right? Also notice that we were able to string together multiple conversions, right? Multiple transformations, right? One of them formatted it nicely so we can read it, whereas the other one ordered it in the order that we wanted. You can string them together in any particular order, right? You'll get the result. Make sense? All right. Right. So notice that the output of one of the operations, right, is the input of the next operation, right? And you get the resulting at the end. There's quite a few of these selectors, right? And you should be somewhat familiar with some of these, right? How these work. There's equals, right? Just your pattern matches to see that whether two things are equal, greater than, less, greater than, or equal. In allows you to give an array of integers or an array of strings, and the field will be compared against all the values in that array. Less than, or equal, not equal, and not in. Right. And again, you can take a look at the documentation in Mongo to play around it. But in general, we expect you to be familiar with these operations. Right. There's tons of them. There's way too many, but these are the absolute minimum that you should feel comfortable with. How they work. Also, there's a couple of logical operators. Of which you should be familiar with and, not, nor, or. There's some grouping aggregation operators that we're not going to ask you about these, but it'd be a good idea to just go and peruse through how they work. You can just like you have aggregation in relational databases, where you can give compute averages, minimums, maximums. Right, same thing. You have aggregation operators here as well. You can group by a particular field, and then you can ask for aggregate functions such as count, average, max, min. Also, you can, just like you can do pagination in relational databases in MySQL, either using limit. Right there, you have equivalent operators here as well. Limit allows you to specify which range of values you want. Whereas skip allows you to skip over the first 1,000, the first. So together, right, limit and skip allow you to do pagination.